All right, good morning, guys. Today we're going to be covering 10.3, surface area of cylinders and spheres. The depth of knowledge is a level 4, meaning it's fairly difficult, and our learning target, what you guys will be tested on, is I can find the surface area of cylinders, spheres, and composite figures. Now, composite figures isn't something that we've necessarily messed with that much so far, but a composite figure is just two of these different three-dimensional shapes put together. So like I put together a hemisphere and a prism, or I put together a cylinder and a triangular prism, or something like along those lines. So that is what we'll be dealing with today. To get started, we're going to focus in on our cylinder. So here's our cylinder, and of course we have our 3D figure and our 2D net here. Now, if I want to know the lateral area of my cylinder, again, the lateral area is just the side area. And the side of the cylinder wraps around it like this. So if I want to know that, the best way that I can think of what occurs is to think of a can of soup. If you were to pull a label off of a can of soup, what shape would that label be? Well, that label would be in a rectangle. And the distance along the top of that rectangle would be the distance around our circle, also known as the circumference, 2 pi times r. Meanwhile, the width of this rectangle would be the height of our cylinder. So therefore, lateral area is equal to 2 times pi times r times h. And that's how you can always find the lateral area. Meanwhile, our surface area is also including the two bases. So again, we have a base on bottom and a base on top. We can see that in our net here and also in our three-dimensional figure. And both of those bases are circles with radius r, so the radius didn't change. So big B will turn into pi r squared. So therefore, surface area is equal to 2 pi times r times h, the lateral area, plus 2 times the area of two circles, pi r squared. Now, again, I just want to make sure that I'm showing the lateral area in blue and our two bases in red. Because every time that you solve for these, you're going to solve for the lateral area first, and then you'll solve for the two bases and add it to your lateral area to get your surface area. Again, the top of our rectangle here, this is just the circumference of a circle. And if you ever get stuck, think about that can of soup. If you want to bring in a can of soup on test day, feel free to do that. That way you can kind of peel off the label and be like, oh yeah, that's a rectangle. All right, let's go ahead and try out a sample problem with this. Each aluminum can is a right cylinder, meaning the height and the base intersect at 90 degrees. They're perpendicular to each other. Find the amount of paper needed to make the can's label, so that would mean that we need to find the lateral area, and also find the total amount of aluminum needed to make the can. That would be our surface area, because that would include the top and the bottom. We're going to round to the nearest tenth. So again, paper is our lateral area. We can find that by doing 2 times pi times r times h. And if we look over here, we're already given the radius 3 and our height 9. So plugging in 3 and 9, we'll get our lateral area is equal to 2 times pi times 3 times 9. Well, 3 times 9 is 27. 27 times 2 is 54. 54 times pi is 54 pi. If you do 54 pi in your calculator, you'll get 169.6 centimeters squared. So that's our lateral area. That's the distance around our figure, just this curved part. If I want to find the total amount that we need for aluminum, including the two bases, well, I need to find the area of those two bases. And since they're the same circle, they should have the same area. So therefore, for my aluminum, I'm using surface area. That'd just be my lateral area plus 2 times b. If I want to solve for b, well, since that's a circle, we'd use area of a circle, pi r squared. So therefore, that'd be lateral area plus 2 times pi r squared. Well, our radius is 3. 3 squared is 9. 9 times 2 will give me 18. So therefore, I have 54 pi plus 18 pi. 54 pi plus 18 pi will give us 72 pi. And 72 pi, if you enter that into your calculator, you'll get the final answer as about 226.2 centimeters squared. And again, we want to round to the nearest tenth, so that's why we went ahead and entered it in. If it said to leave your answer in terms of pi, we would have just said 72 pi. So again, make sure that you're paying attention to what they're actually asking you to round to. All right, next up, we're going to focus on spheres. Now, spheres, very similar to cylinders in that they're round shapes. But beyond that, so many differences. So, surface area for spheres is extremely simple. The equation is 4 pi times r squared. So the only variable that you need is the radius. Now, there is no lateral area for a sphere because there's no side of a sphere. It's a ball. So there's no bases, so I can't distinguish between lateral area and surface area here. There's only surface area. So let's go ahead and try out our surface area equation. From the center of Earth to the surface is 3,950 miles. Now, if you asked me, that sounds like a radius. It goes from the center of the Earth, which is a sphere, to the surface of the Earth. So we have a radius of 3,950 miles. We want to find the surface area of the Earth rounded to the nearest million miles. In order to do this, we're just going to go ahead and use the surface area of a sphere, 4 pi times r squared. Plugging in 3,950 for r, we're left with 4 pi times 3,950 squared. 3,950 squared will give you 15,602,500. If you multiply that by 4 pi, you're left with 196,066,797.5 miles. Now, again, we want to round to the nearest million miles. So again, my significant figures, I have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. So I look at the significant figure right next to millions, and it's a 0. Since it's a 0, I round down, so we're stuck at 196 million miles. That's the surface area of the Earth. Now, 70% of the Earth's surface is water. So if I want to know how much water is on the Earth's surface, I'm going to take the total amount of miles that are around the Earth and multiply it by 70%. Well, I need to switch 70% to a decimal. So 70% is the same as 0.7. So I do 0.7 times 196 million. That will give us 137 million miles. Again, we want to round to the nearest million miles, so make sure that you're rounding to the closest million. All right, let's go ahead and focus in on another sphere. So this time we're going to find the surface area of this sphere, and we're going to leave our answer in terms of pi. So to get started, they give us the area of this circle here. Now this circle is called a great circle. And a great circle is called a great circle because it goes through the very center of our sphere, meaning that it crosses not only through the diameter, crosses not only through the diameter of our circle, but it also crosses through the radius of our circle. So they're giving us the area of this circle. And since they're giving us the area of the circle, what I could do is I can use that to find the radius. If I know the radius of the circle, then I have the radius of the sphere. So I'm going to plug this into our area formula for a circle. 36 pi equals pi r squared. From here, I'm going to go ahead and solve for r. Because if I solve for r, then I have everything that I need for the surface area of a sphere. So the first thing I do is divide both sides by pi, leaving me with 36 equals r squared. From there, I take the square root of both sides, and we're left with r equals 6. Now that we have r, we can plug it into our surface area formula. Surface area is equal to 4 pi times r squared. That'll give me 4 pi times 36. 4 times 36 is 144 pi. So that's our final answer for our surface area, 144 pi centimeters squared. Again, we're leaving our answer in terms of pi, so I don't need to multiply. All right, let's go ahead and try this one out. Pause the video if you'd like and try it on your own. It's very similar to a couple slides back if you need an example. It tells us a planet's radius is approximately 2,900 miles. About 2/3 of the planet's surface is covered by water. Enter an estimate for the land area of the planet. Round your answer to the nearest million miles. So first off, we need to find the surface area of this planet. And they're telling us the radius already. They're saying radius is 2,900. So we can go ahead and plug that into our surface area formula, 4 pi times r squared. That'll give us 4 pi times 2,900 squared. If you enter 2,900 squared into your calculator, you'll get 8,410,000. Multiplying that by 4 pi will give us 105,683,176.9 miles. Now again, we're rounding our answer to the nearest million miles. So looking at this, I look at my millions significant figure, it's a 5, and then I look at the 100,000th significant figure right next to it. It's at a 6. If that figure is at a 5 or larger, I round my millions up to 106 million. From here, we want to know how much land area the planet has. They're telling us that 2/3 of the planet's covered by water, which means that 1/3 is covered by land. So if I multiply 106 million by 1/3, I'll be left with our answer for the amount of land for square mileage. That will give us 35 million miles squared. That's the land mass for that planet. All right, let's go ahead and try out our next one. Next, we're going to talk about hemisphere. So we're going to find the surface area of the hemisphere. Now, if we think about a hemisphere is just half a sphere. So therefore, its surface area should be half a sphere. Well, if half a sphere is 4 pi times r squared, the hemisphere should be 4 pi times r squared divided by 2. Now, I'm also including a base, because when we cut that sphere, it creates a circular base on the bottom. So we also need to include that into our formula. So that's pi r squared because it's the area of a circle. Now if we simplify this further, this will give us 2 pi times r squared plus pi r squared. If I combine these two together, we're left with 3 pi times r squared. That is equal to the surface area of a hemisphere. Again, make sure that you have this equation, as well as this top equation in your notes. And the reason I say that is because this is really good whenever you're just given a hemisphere like we have here. However, this top one's extremely good for composite figures down the road. So make sure that you have both of them. Now, if I want to find the surface area of this hemisphere, I see that the radius is 8, so I can just plug 8 in. That'll give me 2 pi times 64 plus 64 pi. 2 times 64 will give me 128. 128 plus 64 will give me 192 pi. So the surface area of this hemisphere is 192 pi units squared. Again, I left my answer in terms of pi. If you want to round to the nearest tenth, you just need to multiply it by pi. All right, now let's go ahead and move on to our last topic of the day, composite figures. Now with composite figures, these are the hardest parts of this entire unit. Now, the main things that you need to keep track of when dealing with composite figures. First off, we're finding surface area of all of these. Keep in mind that surface area is only the area that's facing the outside. Think hard when determining what you should use to find the surface area. Make sure that you're planning it all out with your formulas beforehand. These are typically difficult questions and a bit tricky. Lastly, be careful if a base is covered up. If a base is covered, that means it's not facing the outside. If it's not facing the outside, we don't include it with the surface area. That's what makes this the most difficult. Let's go ahead and try one out. We want to find the surface area of the composite figure. So looking here, we have a rectangular prism on bottom and a hemisphere on top. I'm going to go ahead and start with the prism on bottom. To find the surface area of a prism, we have the equation, surface area is equal to the perimeter of our base times the height of our prism plus 2 times the area of our base. That'll give us 10 plus 7 plus 10 plus 7 times 4 plus 2 times 10 plus 7. 10 times 7 is 70. 70 times 2 is 140. Meanwhile, over here, 10 plus 7 is 17. 17 plus 17 is 34. So we're left with 34 times 4 plus 140. 34 times 4 will give us 136. 136 plus 140 is 276 units squared. Now that I have my prism, I'm going to move on to my hemisphere. And to get started, I'm going to go ahead and treat it like a sphere. And I know that the equation of a sphere for surface area is 4 pi times r squared. So from here, plugging in my radius of 3, we're going to have 4 pi times 3 squared, or 4 pi times 9. That, of course, will give us 36 pi units squared for a sphere. But we don't have a sphere. We have a hemisphere. So I divide that surface area by 2, and I'll be left with my hemisphere of 18 pi. Now, you may be thinking, Mr. Garner, what about the base? It's still here. Well, remember, this base is covered up. And if that base is covered up, we don't want to include it. And the problem is that we already included it. We included it when we found the surface area of the prism, because that included the entire area around the prism, including this circle. When we found the hemisphere, we only found the curved part, because we didn't include the base. So now we need to get rid of this base, because again, the base is already included within our surface area of a prism. So to find out this base, I need to find out the area of it. And since it's a circle, I can use pi r squared. So here's our danger warning. This base is not showing, and if this base is not showing, then we need to get rid of it. So we can get rid of it by doing pi r squared. Again, the radius is still 3, so therefore we have pi times 3 squared, which is 9 pi. From here, I'm going to go ahead and combine to get our total surface area. So I'm going to do 276 plus 18 pi. That'll give me everything, including this circle that's covered up. So from there, I'm going to subtract 9 pi, and that will give us the total surface area. So we're left with 276 plus 18 pi minus 9 pi. 18 pi minus 9 pi is just 9 pi. 276 plus 9 pi will give us about 304.3 centimeters squared. Let's try out one last problem for the day. One more composite figure. Again, we have a rectangular prism on bottom, a cylinder on top. If we look at this, we see that our cylinder on bottom is covered, so we don't want to include that. We don't want to include this base. If I look on top, this base is not covered. However, if I find the surface area of the whole prism, it will include this circle. Because if I just shrink this cylinder into the figure below, this circle will cover this circle. So therefore, the surface area of the prism will include this top base, which means all I need is the surface area of the prism and the lateral area of the cylinder. Let's start with the prism. For the prism, we have perimeter times h plus 2 times our base. Perimeter will be 9 plus 4 plus 9 plus 4 times our height 5 plus 2 times length times width of our base, 9 times 4. From here, 9 plus 4 is 13. 13 plus 13 is 26. 26 times 5 is 130. Over on the other side, we have 9 times 4, which is 36, times 2, which is 72. So we have 130 plus 72. That will give us 202 centimeters squared for the prism, including this top base. Next, we need just the lateral area of our cylinder, which is 2 pi times r times h, because again, this base is covered, and this base was included in our prism. From here, we see that we have a radius of 2 and a height of 3 for our cylinder. So therefore, our cylinder's surface area will be 2 pi times 2, which is 4 pi. 4 pi times 3, which is 12 pi. So our cylinder's surface area is 12 pi centimeters squared. Lastly, to find the composite figure's surface area, I just add these together. And no, I don't need to find any more bases, because again, the top base is covered by the prism. The bottom base is covered, so we're not going to include it in a formula at all. So adding these together, 202 centimeters plus 12 pi centimeters, we're left with 239.7 centimeters squared. All right, guys, thank you so much for watching today. If you have any questions, please reach out and let me know. Other than that, thank you so much for watching. Have a great rest of your day.